Okay, so we are, to repeat, we're going to try delta equal to epsilon and see what happens. Thus, if this is the case where x is within delta of the number 4, that's what this means, although it's not equal to the number 4, so we just repeated this right here. If it's less than delta, which we're saying is equal to epsilon, that means that f of x minus 3, and what I want to have happen, I hope eventually after some arithmetic, we're going to see that's less than epsilon and we'll be done. Well, let's do some algebra here. F of x minus 3. Okay, where did I define f of x? 3x minus 9. Minus 3, I'll put the 3x minus 9 in parentheses to differentiate it. 3x minus 9 minus 3 is 3x minus 12, which we can write like 3 times x minus 4 in absolute values. And the nice thing about that is x minus 4, we know something about that, right? We know that x minus 4 in absolute values is less than delta. So I can say that this is less than 3 delta, which is equal to 3 epsilon. So we didn't quite get what we wanted. I wanted that to be less than epsilon, and we got 3 epsilon. So what could I do here to take care of that? What could I tweak? Well, it turns out that all we needed to do is say, yeah, 1/3 of epsilon, exactly right. So if we choose that, then delta is epsilon over 3. Now I can change, now 3 delta is equal to 3 times epsilon over 3, which is just epsilon. And that completes the proof. Now I may make a note down here. Actually, I'll just speak it. Any ideas why the number 3 showed up here for 3 delta? Essentially, it's because this equation, where's f of x? Right here, has a slope of 3. If the slope were 5, we would be using epsilon over 5. If the slope were small, absolute value less than 1, we could simply have used delta equal epsilon and it would have worked just fine.